So that is about our data types, right? What we have learned so far, we have learned data types. What are data types? Like we have learned mostly primitive, right? Of course, we will try to learn those abstract data types in our future classes because those are the most important things for us. But before learning those things, we need to know primitive data types. So we have learned primitive data types, and we have learned what? We have learned how to find that range. That means if you are writing something like int a equal to 5, you need to know that whether I am okay to write this 5 or not, because you need to know what is the range. If you know the range, then you can write whatever number here cautiously, okay, without any ambiguity. That is the most important thing, right? So we have learned the ranges part. Now we will learn what are operators, and this is the last topic of our video, right? So we have seen operators in many things, right? Like, we have learned in our C programming as well, and most of them who are having a good knowledge about programming, uh, they could have learned operators in their first lectures itself, right? So operators, you have unary operator, you have binary operator, you have ternary operators. You can see plus plus minus minus, and you can see plus plus minus minus are what? Increment decrement, right? And you have basic addition, subtraction, multiplication, division, modulo. You know modulo, right? Modulo gives you the remainder. And you have relational operators, which are less than, greater than, less than or equal to, greater than or equal to, double equal to, not equal. These are things. And you have logical operators. If you want to check logically they are true or false, you can use logical and, logical or logical not, right? Let me try to erase and use laser, right? And you have bitwise in the sense bit by bit you are checking, right? And or you have left shift, you have right shift, and you have negation, and you have XOR, right? I think you know these things, right? This is XOR, and this is you know negation, right? We'll try to learn in the next slide, don't worry. These are the assignment operators. Basically, you know it, right? Equal to, plus equal to. That means plus equal to in the sense addition as well as this equal to operation must be performed simultaneously. Similarly, star equal to, which is multiplication, and division equal to, modulo equal to, and finally you have ternary operator. Ternary operator is basically a replacement for if else statements, right? So that is about these operators. Let's try to, in this session, we will try to learn more about, this bitwise operators, right? Bitwise operators, because as a part of our programming, bitwise operators are important. Remaining things are, cup of tea for every people, everyone, right? So that's why just wanted to tell in detail about this bitwise operator. If you take two bits, A and B, A contains zeros and ones, and B as well. It also contains zeros and ones. You can check, this is something like a 2-bit representation which you have seen earlier, right? 0 0 0 1 1 0 1 1, right? We have basically four things here, and this is and this is or, this is XOR, okay, this is XOR, and this is not, or you can say negation, okay. Basically you will have this key in your computer as well, right? So if you take two, these bits, if it is an and, just remember one thing, okay? Don't try to learn these all things. I'll tell you a shortcut, okay? If it is and, if both of the bits are 1, then it is 1. Otherwise, it's 0. Whatever case may be, if there is no 1 in both of them, then it is definitely 0. If you have both of them as 1, then it is 1. You can check, here you have 1, here you have 0. Here you don't have 1, so it's clearly 0. Here also you don't have 1, so it's clearly 0. Here also you don't, here both are zeros, so it's completely 0, right? So once again I'm repeating, if you have both of them 1, that means both of the bits as 1, it's 1. Otherwise 0. Simple funda, right? Similarly for OR operator, if both of them, let me try to show again. For OR, right? Let's check for this thing. For OR, and you need to check from this box, right? For OR, this is OR symbol. Remember, if you have 1 in any one of them, then it's 1. Here in both of them you have 0, so it's clearly 0. Here you have 1 in one of them. In this both you have 1, right? So it's 1. Similarly in this both you have 1, so it's 1. Similarly in this both, here both are 1, so clearly it's 1. So that means in A and B bits, if you have any one of the bit as 1, then it is 1, otherwise 0. So 0 is the case which you will get when both of them are 0. That means when you don't have 1 in any both of them, then it's clearly 0. So and or are something which are so confusing, right? But it's definitely easy if you do it with practice. Simple. Remember, for and, if if both of them are 1, then it's 1, otherwise 0. But for or, if any one of them is 1, then it is 1, otherwise 0, right? Similarly, I'll tell you the same thing for XOR. For XOR, if both the bits are same, then it is 0. Here you can check 0 0, both are same, so it is 0. Here also 1 and 1, both are same, that's why 0. If both are not same, here both are not same, right? So it's clearly 1. That's it. Simple. XOR is very easy, right? Similarly, negation, right? Negation in the sense it's something like it's not applied between any two, because negation you can apply either for this or this. Negation of A in the sense this 0 will change to 1 and this 0 will change to 1. This 1 will change to 0. So it's opposite, right? If it is plus, it's minus. If it is minus, it's plus. Something like that, right? So once again, I'm repeating, very simple. For AND, what is the statement? If both of them are 1, then only 1. So here, why it is 1? Both of them are 1. That's why it's 1. Why here you are getting zeros? Because both of them are not ones. Simple, right? Then for OR, if any one of them you have 1, then it is 1. Here you have one of them 1. You have more than 1, right? Like you have two ones, right? So that's why it's 1. Here you have 1 1. It's okay. It's 1. Here also you have 1 1. It's 1. But here both of them are zeros. So that's why you got 0. Similarly for XOR, as I said, if both are same, then it's 0. So these are the cases. Both are same, that's why 0. Otherwise 1, right? And negation, it's opposite. Plus minus, minus plus. Something like that. That is about, bitwise operators. So basically, you might be getting one doubt why I'm, discussing more about this bitwise operators, right? Basically, the first topic that we are going to start as a part of our data structures is bit manipulation. That means we'll try to solve and we'll try to completely understand the topics related to bits. Okay, we'll just try to play with these bits as much as possible. So that's why I'm trying to give some basic understanding about this bitwise operators more. Remaining operators, you know them, right? You could have done many, basic programs in your programming, right? As a part of your programming. So that's why I'm telling bitwise operators. Now, the next thing we are going to talk about is cheat operators. Don't think this is a name, right? I've given it a name as cheat, but don't try to learn it as cheat operators. Okay. So what I'm trying to tell as a part of this is, while you're solving some problems, there is no scope that you try to, you know, try to do it as long as possible. Suppose, uh, let's say you are given some task, right? If you are given some task, then it's important that if you need to know some formula or something like a cheat code for it, instead of solving it in depth, trying to know about it in depth. Let's say, take the example of previous thing, right? We have seen how to find ranges. We have seen how we are basically getting a range for integer, how we are getting a range for long, these things, right? We have seen how we are getting, but not every time you do those things, right? You need to know how we are getting. That's important, you need to know. But sometimes while you are in some tough situations, or if you have limited time, then definitely you need to keep them in your mind and go, right? That doesn't mean you don't know, but definitely it's important that you need to keep them in mind. Let's say 1 plus 1 is 2, right? You know it as 2 because it got just stored in your mind. 1 plus 1 is 2, but you don't try to in detail do it, right? Like 1 plus 1, it's 2, that's something like that, like this. So that's why for that thing I'm trying to give you these cheat operators. That means you don't find any problem with while solving problems, right? The first operator is a and a. Let's take an example of a as 1 1 0, or let's take some small example, right? Let's say you have 0 1 0. Okay, so what is the value for it? Can you tell me? The value is, it is here, it is 2 power 0, here it is 2 power 1, here it is 2 power 2. I hope you know these things, right? So 2 power 0 into 0 is 0. 2 power 1 into 1 is 2. Similarly 2 power 2 into 0, 0. So value for this is 2. Let me erase this thing. Okay. Now if I apply AND with the same, representation, like if I do AND 0 1 0, if I do AND for this thing only, what you're going to get? Can you tell me? 0 and 0 is 0 because both of them are not ones. Here you got both of them as ones, so it's clearly 1. Again you got 0. So you can clearly check, if I do A and A, then I am going to get A itself again. Try to check with whatever example you want, you will get the same thing. Okay, so here it is a cheat operator. Whenever you're solving problem, let's say you're doing some loop, right? You're working on loops. You got something like this, while you got 1 and 1. Don't try to solve like this, take representation for 1, take representation for 1, not like that. You know that whatever and that I apply with same thing, I'm going to get the same thing again. So 1, instead of writing 1 and 1, just replace this with this entire thing with 1. So instead of while 1 and 1, we're writing while of 1. So it's very useful, right? That's why I'm telling, these are some of the cheat operators that you need to know, right? So A and A is clearly what? It's A. Similarly, if I take A or A, that means, let's say, let me take 1 0 as same example as A, and for the same thing, I'm applying OR. 0 or 0 is how much? 0. 1 or 1, 1. Because any one of them could be 1, but you got as 1 as both, so it's 1. Again 0. Oh my god, again you got the same thing. You take any example, you'll get the same thing only. So clearly you got here two important things. What are those things? If both the, let's say both the values, let's say both the values are same, and if you apply or or sorry, or, that middle or is not the bitwise or, okay. So if you try to apply this or if you try to apply this or, then you're going to get the same number. Okay, very simple. Similarly, you have both the numbers, let's say 0 1 0 A, and if you apply XOR, now you are applying XOR, what you are going to get? XOR in the sense, if both are same, it's 0, otherwise 1. Here you can check 0 0, both are same, 0. 1 1, both are same, 0. 0 0, both are same, 0. It is the entire 0. So clearly, if you can take any example, but if you do XOR with two same numbers, you are going to get 0. So if you do XOR with two same numbers, you are going to get 0. Simple. So you got three important operators, right? You learned some good thing today, right? Similarly, you can take this example, right? I'm not, trying to explain this, but you can do it yourself, right? If you take any number, you take any number. A is nothing but any number, right? Trying to write here any number, right? Make sure that you try to do bitwise operation, not number, right? Take any number, and if you do AND with 0, you are going to get 0. Let's say same example, 0 1 0, and if you do AND with 0, 0 in the sense all will be zeros, right? Now if I apply AND, 0 and 0 0 0 again 0, because both of them, one is nowhere present, again you got entire 0. So if you take any number, apply AND with 0, you are going to get 0. If you take any number and apply OR with 0, you are going to get the same number. Now here another interesting case. Let's take this case, right? Let's say A is 0 1 0, and if I apply OR operator with the 0, that means all are zeros, you're going to get what? 0 or 0 is 0, 1 or 0 is 1, 0 or 0 is, so you got 0 1 0, which is same number again you got. That's why I've written here A or 0 will be A itself. Okay, so simple funda. Now if you take XOR operator, similarly take any A as something like 1 0 1, and if you apply XOR with 0 0 0 0, XOR in sense if both are same it's 0. Is both are same? No. So it's 1. Both are same? Yes. 0. Both are same? No. So 1. You got again same number. So if you apply XOR with the any number with 0, you are going to get that any number only. Now again you got one cheat, right? Some cheat code. So how you will learn, it completely depends on you, right? And clearly check when you are getting 0, when you are getting 0, when you apply XOR with same numbers, or when you apply AND with 0, you are going to get 0. Other than that, you are getting A only. So you got some cheat, right? Some interesting thing here, right? So similarly, you have another set of cheat operators. Okay, I would like to leave this cheat operators to you. You try to work on it, right? Of course, I will explain it in the next video. But if you work on it, then you will get to know, right? Here I've written something like even equal to 0, odd equal to 1. What does this mean? That means if this integer a, if it is even, then you are going to get 0. But if this a is odd, then you are going to get 1. Is it so? Is it really? You need to check it. You need to check it. Let me try to say with this one example. Remaining to you try to do it on yourself, and you let me know in the comment section, okay? Whether you got the same thing or not. Let me take a as 101, right? And if I apply AND with 1, that means 0 0 and 1. Let me clear you that this a, whatever 101 I have taken, what is this? 1 plus 4, it is 5. So clearly it is odd number. So a, I have taken odd number and I am applying AND with 1. So let's check. 1 and 1 is 1. 0 and 0, 0. 1 and 0, 0. You got how much? 1. So if A is odd, and if you apply A, that means if you apply A and 1, then you will definitely get 1. So that's why I've written A and 1. For odd cases, I have written as what? 1. Okay. Similarly, for even case also you can check. Let's say I have taken 0 1 0, which is 2. This is my A, okay? And if I apply AND with 1 0 0 1, you will get how much? 0. That you can check, right? There is no 1 1 combination. So again, if you apply A with this 2, oh sorry, if you apply A which is an even number, and if you apply this AND operation with 1, then you will definitely get 0. That's why I've written here. For even case it's 0, for odd case it is 1, right? So that is the idea of this cheat operators. You just try try on these two things and let me know, right? These two things. Now we will discuss if possible in the next session, and if you do it, it's so good, right? Now there is some more cheat operator, most important cheat operator. I want to tell you this cheat operator, right? This is the most important one you will use in most of the problems. Okay, now what is this cheat operator, right? I have told here a and 1, a mod 2, both are same. That means you take any value of a, you apply and with 1, and you apply mod with 2, you are going to get the same value. That means both are same, both are literally same. That means if I have written something like while a and of 1, then this is completely equal to while a modulo 2. So instead of doing this complex bit manipulation, you can simply say a modulo 2. Let me see. We are telling both are same. You need to check with example, right? A is, let's take 101. And if I apply and with 1, this is 1, right? Again, remember 1 is, I have taken this as in binary. 1 is also in binary. It's something like this, right? 2 power 0, which is 1. So if I apply and, you are going to get 1, which is what? 1. So let's say a is what? 101. 101 in the sense 1 plus 4, right? It is 5. So if I do 5 modulo 2, that means a modulo 2, how much? 1. So clearly both are same. So that's why I'm telling you can check these examples, right? Here also I have given the same example. You can check with another example as well. A and 1 and a modulo 2, both are same, right? So that is the cheat operators. Very important thing you have learned here, right? Don't try to remember these things, okay? Of course, it's very easy if you try to solve them, but you can clearly, in a simple format, like both are same, then same. But for only and or. For XOR, it is 0. Similarly, with respect to 0, I mean A and 0, A or 0, A XOR 0, these are the cases. Similarly, with respect to 1. So here only this right side part is changing. Here it is A, here it's the same number, and here it's 0. Here I have checked with 1, right? So that is the idea. And similarly, the most important one, this thing. It will be useful in most of the problems. This thing, right? So that is about some of the cheat operators, and these two cheat operators you can do it. If you have any doubts, you can post in comment section. Now let's try to learn some simple things finally, right? In max you have seen something called as associative or commutative properties, right? So here also we are going to check the same thing. A or B is nothing but B or A. You could have seen something like A plus B is nothing but B plus A, or A into B is nothing but B into A, right? You could have seen in your max. Similarly for this bits, these operators also same functionality. If you do and A and B, which is equal to B and A. Similarly A, this is the associative property. These two are commutative, right? These two are commutative, and this is the associative property. If you do A or B or A, it's simultaneously or simply equal to A or B or whole of RC. That's it. Okay, that means these are the three important, some basic commutative properties that you can check out. Now, talking about the last topic, right? Operators, important operators, left shift operator and right shift operator, right? Now, let's say you have some number, something like 10101 as given, right? I have given here. As I said, this part is the low LSB, that means least significant bit. That means this is having some least significance, and this bit is having most significance. You know why this bit is most significant? Because this bit is going to tell you the sign, whether it's a positive or a negative, right? So let's don't go deep digger into this significant bits. But before that, I want to tell you what is a left shift. Left shift in the sense you are shifting it left side. That means, sorry, that means you can check here. I'm shifting all these bits, whatever are there, right? All these bits, right? I'm shifting them towards left. You check 1 I have shifted to left, 0 I have shifted to left, 1 I have shifted to left. Similarly, this 0, this 0. I've shifted everything. After shifting everything, at last I am inserting 1 0. This gives you the new thing, right? Now, what we are doing actually, why are we shifting? Because in problems, they will say something like, let's say this 1 0 1 0 1. What is this value? Can you tell me? 2 per 0, which is 1, 1 plus 4 plus 16, right? 2 per 0, 2 per 1, 2 per 2, 2 per 3, 2 per 4, yeah, right? So it's how much? 21, right? So 21, if I left shift by 1, then you are going to get this answer. Remember, right? If I left shift 21 by 1, I am going to get what? This answer. What is this answer? New answer, can you tell me? It's 2 per 2, which is 2 per 2, 2 power 4 and 2 power 6. So it's how much? It's a big number, right? 2 per 2 is 2, 2, and this is 4, this is 8, this is 16, this is 32. So you got how much? 32, 42. So if I left shift my 21 with 1, I'm going to get 42. So for left shift also you are having some answer, right? But is it the same thing you do every time? What you are doing here, you are maintaining the same table of this above thing only, but what you are doing, you're one extra one here, but you are shifting them, right? 1 comes here, 0 comes here, and this 1 comes here, and this 0 comes here, and this 1 comes here, and finally at last where there is some empty thing which you are filling it with 0. That's it, simple. You're doing it easily, right? But is it the same thing you are going to do every time? No, right? No. Let me tell you how you can do it, but before that let me also tell you right shift. If you know left shift, then is it a problem to understand right shift? Let me tell you, right? 1 0 1 0 1. Take the same thing of the above, right? Take the same thing again, but here you do right shift. That means this one will come here, and this 0 will come here, and this one will come here, this 0 will come here. But here you are having one more one, so this one you are getting here. And finally, you have one more doubt. What will be the first, this box, right? It is filled with 0. But remember, in right shift, you are going to neglect this last part. You are going to neglect this last one. That means whenever you are doing right shift, you are simply neglecting this last one, isn't it? You are doing it, right? But you can clearly check what we are doing literally. We are trying to remove this one and we are trying to add 0 here. Simple. In right shift, right? Similar in left shift, what you are doing? You are simply removing this one and you are adding 0 at the last. So it's very easy, right? Instead of taking this box and doing, if you have given any number, let me clarify you here. Suppose let's see 1 0 1 0 2 1 1 0 1. If you are given some big number, if you want to do left shift one time, then what you are going to do? Simple funda. You will remove this one and you will add one extra 0 at the end. Similarly, if you want to do right shift with one, what you will do? Tell me what you will do. Similarly, right shift with one will you will simply remove this one and you will add 0 here. So simply left shift means you are removing the leftmost thing, and sorry, let me write it clearly. Left shift means what you're doing, you're simply removing the leftmost thing and you're inserting 0 at the end. Right shift means you're simply removing the right side thing and you're adding 0 at the start. Simple. So in simple terms, if you want to tell me, if you want to do left shift, remember, for any binary number, simply left shift. That means, remember, important thing, left shift means you need to remove the left side number and you need to add a 0 at the end. Right shift means you need to right in the sense you need to add something at the hmm, something at the, for left shift you are adding at the right side, something here right side, right? But for right shift you are adding here and you are removing this thing. In simple terms, again, don't I'm not making it complicated, but I want to tell you in simple terms. Okay, you just try to remove, for left shift you remove the left one, for right shift you remove the right one, but make sure that in left shift if you have removed the left one you add a 0 at the end, and in right shift if you have removed the right one make sure that you add 0 at the left. That's it. Now you got some idea, right? I hope you got some basic idea, right? And if you are facing difficulty again here, then you have a formula. What is this formula? If you want to do any integer a, you want to do left shift I times, don't do as I said in this boxes thing or something like add 0 at the end, I mean at the left and add 1 at the right, something like that. Instead of that, if you have given something integer left shift I times, for one time you know it, but for I times, then simply what you are going to do, you are going to multiply that integer with 2 power I. That means if you want 21 left shift one time, previously we have got answer, right? What is the answer? 21 left shift 1, we have got 42, right? If you have remembered previously. So I will use the formula here. 21 into 2 power 1. 1 here I is 1, right? So 42. You are getting the same answer. So if you want to do left shift I times, then multiply that integer with 2 power I times. If you want to do right shift I times, simply divide that integer with 2 power I. Instead of multiplying, only thing is you are dividing. That's it. Now you might be getting some doubt how you got these formulas. It's very simple. I want to give you as a homework because I cannot explain you here because video goes too long. But of course, if you don't get it, then definitely I'm here to solve it. Take an integer. Let's take 21. You do 21 left shift 1 and you find out what is the answer you got. Similarly, take 21, you do left shift 2 times. That means this previous answer only you do one time left shift, then you'll get left shift 2 times, right? Similarly, do 21 left shift 3 times. You'll get some answer. And you can check the flow of these answers. You'll directly get this formula only. Just like how previously we have seen, right? For unsigned int, we have got one range. For signed int, we got some range. And from this range, we have derived some 2 power I, also 2 power n minus 1, something like formulas, right? So in a similar fashion only, I have done here, right? It's very simple. You can do that as your homework, right? Or as a practice, you can do left shift 2 times, something like this, and you will get some answers, and you can compare those answers, which will give out you this formula. Similarly for right shift also, like 21, do right shift 1 time and find the answer. 21, do right shift 2 times and find the answer. So do the same things. You'll get again a pattern here. Based on this pattern, you can derive this formula. So instead of doing every time shift, like instead of these boxes, or simply like adding 1 here, adding 0 at another end, or discarding 1, not adding 1, adding 0. So you can simply do what? A into 2 power I, A divided by 2 power I. That's it. Simple, right? So it's very simple. Left shift and right shift, right? So these are the operators that I wanted to learn you today. That is about this video, right? Let's try to sum up whatever we have learned till now in, as a part of this series. We have learned what are the what is the definition of data structure and algorithm. We have learned what are, primitive types and what are abstract data types, right? Abstract, of course, we'll learn in future. Primitive, we have got some strong, settlement over here, right? Whoever asks us, you can simply answer. And we have seen some, what is the length of, size of them. And we have seen why we have done, it, right? For 2-bit, for 3-bit, we have derived for 32-bit. That is for an integer. So we have derived a formula for an integer and we have done something so that we can easily remember, right? By applying formula. Similarly for 3-bit, we have find those ranges, right? So after finding those ranges, what we have done, we have found the formula and we have normalized this in the form of 10 powers. That means 2 power 30. We have something normalized it as 10 power 9, right? I mean 2 power 10 we have normalized at 10 power 3 and 2 power 30 we have normalized at 10 power 9, something like that. Similarly, we have seen these constraints most important in solving the problems, and these are some, other data type ranges. And finally, as I want to tell you, right, if you know the bits, then it's very easy. Just apply the formula, right? And that is about these ranges. We have seen operators, these all operators, but we have focused more on bitwise operators because our aim is to cover the bit manipulation as our first topic in this data structures. I've told you what is AND, what is OR, what is XOR, what is negation, you know, just a trick. And this is very important. You try to, uh, you know, focus on this somewhat more because these are going to help you a lot in many problem solving, things. And finally, we have seen some properties and most important left shift and right shift. We have seen how you can do this in boxes, right, to make it easy. And we have seen like simply for left shift, you can left shift in the sense remove the left side whatever leftmost thing and add 0 at the right, and for right shift remove the right side rightmost part and add the 0 at the left side. And instead of doing these things you can simply apply the formula. That's it, right? So that is about your brief introduction about data structures and algorithms. Okay, so please like and share, and of course subscribe to this channel. It means a lot. Of course you might have liked this video, so try to subscribe and try to share it with your friends as well.